seems to be working today. All right, so let's get in. We're going to talk about a couple of different topics today. The first topic we're going to talk about is I want to actually get into converting some angle measures to the other unit. So from degrees to radians and radians to degrees. We're going to talk about degrees, minutes, and seconds, and then we're going to talk about arc length and the formula that we started yesterday. Okay? So those are our topics today. Okay? So factor label method, you've probably seen in some scientifical type classes. So with the factor label method, what happens is you start out with a value, and in this particular case, the value that we're going to start out with is 6 feet. Then you're going to multiply that by something to cancel out the feet, and you want it to be in inches. So I'm going to multiply it by the fact that 1 foot is 12 inches. Then the feet go away, and all we're left with is inches as the label. That's a good thing. 6 times 12 is 72. So there are 72 inches in 6 feet. Okay. Factor label method is going to come into play tomorrow on the video that you watch about the speed chart. That will definitely come into play for that. It's a fun video tomorrow. I'm kind of sad that we don't get to teach it in live or in person, but the video will still be good. Okay. Same thing with quarts to a gallon. If we start with 32 quarts, and then we multiply by is there 4 quarts or 8 quarts in a gallon? I think it's 4, right? Anybody? 4? I think it's 4 quarts in a gallon. So here now we would have 1 gallon on top, and then we would have 4 quarts on the bottom. The quarts would cancel each other out. We would be left with 32 over 4. And that reduces to 8. So that would be 8 gallons. Quarts. Okay? So we got that going on, which is nice. Okay? Now, that same method, that methodology, if you will be used when we're converting from degrees to radians. Okay? So yesterday we said that the conversion was either going to be 180 degrees over pi radians, or it was going to be pi radians over 180 degrees, depending upon which one you're going to. The left fraction is if you are converting into degrees. The right fraction is if you are converting into radians. Okay? So we have 90 degrees here, and we want to convert it into radians. So we're going to multiply by pi radians over 180 degrees. Okay? Now, when we're multiplying fractions, remember we can multiply straight across first and then reduce, or we can reduce 90 goes into 180 twice, and then these degrees cancel each other out, so we're left with just pi over 2 radians. And so we would write it as pi over 2, not RAR, RAD, or we could write it as pi over 2 with a radian measure with a little bitty r up there, or because it's got the pi in it, we just mathematically assume that it's in radians. Anytime that we see pi, we automatically, higher level mathematicians automatically think that that just means we're in radians because the pi is there. Yeah? So we've got that going for us, which is nice. Okay? So what I would like you to do now is individually, I would like you to convert those two fractions, or those two degree measures into radians. Please do so now. $30 goes into 210 7 times. 30 goes in there 6 times. 45 goes in there 7 times. 45 goes in there 4 times. So on the first one, 315 degrees is 7 pi over 4. 210 is 7 pi over 6. Okay? If you didn't see those, just know that you could always, so if we had 315 over 180, we could divide by 5 first. If I divide that one by 5, I get 63. If I divide that one by 5, I get 36. Okay? Then I could divide both of those by 9. 7 and get 4 that way. You can do it in multiple steps, but we got to get it all the way reduced. Okay? Questions, comments, concerns on that one? Thumbs up, we're good. Thumbs to the side, we can use a little bit more practice on it, which we'll get here in a minute. Thumbs down, we got some questions. I see nothing but thumbs up there. That's great, grand, and wonderful. Let's try these now. Now we're converting, we're in radians. Now we want to convert to degrees. Okay? So when we're converting into radians, fraction form is preferred. When we're converting into degrees, we're kind of like, we'll take it if it's exact, but decimal would probably be better in degrees. So we're starting here with pi over 6 as our radian measure. We would then multiply now by 180 degrees over pi radians. The radians would cancel each other out. 6 would go into 180 30 times, and the pi's would cancel each other out there, making it just be 30 degrees here in the end. Okay? So it's much the same as we were doing, except now our pi is in the basement, or the conversion, the pi is downstairs, so that's where it comes into a little play. What I would like you to do now is I would like you to do these next 3, convert those next 3 into degrees. Radians cancel out. 2 goes into 180 90 times. The pi's cancel out. that leaves me with 810 degrees. Love it. 3 radians. 180 degrees over pi radians. The radians cancel out, but that is all that I can cancel out. So if we were asking for an exact answer here, we would have 540 divided by pi degrees, which, I mean, that's the exact answer, but here's where the calculator would come in. We would much rather prefer 540, and now my calculator is not working again. Clearly. All right, we're just going to close out on it then. We're just going to go regular old calculator. There we go. Back in here. So we would do 540 divided by pi, and we would get approximately 171.887 degrees there. Converting here on 1 radian times 180 degrees over pi radians. The radians would cancel each other out, leaving me in exact form. It would be 180 over pi degrees, or approximately 57.296 degrees. Okay? Expand that down since we're not going to use the regular or the graphing calculator. Okay? So we've got those. Okay? Now, there are some additional degree measures that we have going on there. It's a different way. It's kind of a necessary evil is what we described it as. So a degree, okay? So 1 degree is 1/360th of a circle. 360 degrees all the way around. Actually, I could have just moved that up, I suppose. Okay, so that's 1 degree is 1/360th of a circle. We can handle that. Okay, 1 minute is 1/60th of a degree. Yeah. 1 second is 1/60th of a minute. So the conversions that we need, or the, if you will, the ratios, I think would be another way of saying it. Okay, so 1 degree equals 60 minutes. 1 minute, sorry, I put it like this. Put it in the symbol form. Equals 60 minutes. 1 minute equals 60 seconds. So 1 degree is also equal to 3,600 seconds. Okay? Now, when we are writing out degrees, minutes, and seconds, or DMS as we like to call it, okay, we leave the degree as a whole number, an integer. The degree is going to be an integer with the degree symbol. Minutes would also be a whole number with the minute symbol behind it. Seconds are going to be rounded, because it's the last of them, to usually 1 decimal place. Okay, so we round the seconds to 1 decimal place. Okay? So now what we need to learn is we need to learn how to convert from decimal degrees to degrees, minutes, seconds, or from degrees, minutes, seconds to decimal degrees. Okay? So what we do is, if we are converting to a decimal degree, this number out here, the degree, that's locked in. Okay? So we're going to have 245 plus, okay, then this is a 60th of a degree, so that's going to be 10 60ths of that degree. So on a calculator, we could figure out what 10 divided by 60 is, or simply 1 divided by 6, and we would get 0.1666 repeating, and so on and so forth. So these two numbers here could be added together, which would give us then 245.167 degrees. So 245 degrees, 10 minutes is 245.167 degrees. These out here on the ends, these two right here are equivalent. And those two are the same. One is in degrees, minutes, seconds. One is in decimal degrees. Okay. Same thing if we have all three. So the 148 would be our starting point. The 16 would be 16 over 60. And the 25 would be 25 over 3,600. Okay? Now, the reason that we don't just do 25 divided by 60 is because we want them all in the same unit. So we need them all in degrees. So a minute is a 60th of a degree, but a second, or 1 second is 1/3,600th of a degree. So we need to divide by 3,600 there. So 16 divided by 60 is 0.26 repeating. 25 divided by 3,600 is 0.00694 repeating. Add those all together, and I get 148.2736111111. We'll call it 274 degrees. And again, these two would be equivalents. Going the other way, going into degrees, minutes, and seconds, again, this 345, that's going to be our degree. We can forget about it for now. Okay? So that leaves me with 0.12, and I'm going to multiply that by 60 to find how many minutes we have, and I get 7.2. So the 345, that would be my degrees. The 7 of the 7.2 would be my minutes, because we want whole numbers there. But I still have this 0.2 part, so I'm going to multiply that 0.2 by another 60, and I get 12 there, and 12 then is my seconds. So we're truncating is what it's called. So we're just looking for the decimal part of that. So then our final answer here would be 345 degrees, 7 minutes, 12 seconds. Okay. You try now converting 215.63 degrees into degrees, minutes, and seconds. I get 215 degrees, 37 seconds, or excuse me, 37 minutes, 48 seconds. Okay? That's going to allow us to, knowing how to convert between the two is going to allow us to expand our problem sets, and NTC on your final that you have to take for the dual creditness has some degrees, minutes, and seconds on it also. Okay? Question of the day today in the chat: yay or nay with the snow? Yay if you were excited because it was fresh snowfall and October snowfall. Nay if it's just too early for it to be this darn cold. Okay? Just so you know, we don't have to necessarily do questions of the day anymore, because we get a report now at the end of each class as to who logged in and what times and stuff they logged in. But I still like it because it's topical and it's kind of me getting to know you and all that fun stuff. So we'll still do it in my classes. Okay? Yesterday we learned the mathematical relationship between these three variables. We said that S, the arc length, was equal to theta, and I don't know why our theta suddenly switched to basically a circle with an H around it, but whatever, times the radius. And the kicker for that was the fact that theta has to be in radians. Okay. If theta is in radians, that works. If theta is not in radians, we have to convert theta to radians in order to use this formula. Okay? And we can manipulate that formula to have, we could solve it for r, where we have s divided by theta. We could solve it for theta, s divided by r, and so on and so forth. Okay? So let's get into some word problems here. A circle has a radius of 12 centimeters. Okay? So I know for a fact that 12 centimeters is my r. Central angle theta intercepts an arc length. So my arc length, so that's going to be S, arc length here, is going to be 18 centimeters. Okay? We want to find the radian and the degree. So we're looking for two answers here of the measure of theta. Well, we can start with our formula. S equals theta times r. So my arc length is 18. My theta I don't know. And my radius is 12. Okay? So if I solve that for theta, I would divide both sides by 12. Dividing by 12 then is going to give me that theta here is equal to 3 halves, or 1.5. So let's make it or 1.5 radians there. Okay? Either one of those would work for me there. But that's only the radian measure of that. Now what we need to do is we need to take that 1.5, 3 halves if you will, and we need to multiply it by, we want degrees, so that's going to be 180 degrees over pi radians. So that would be approximately, well, I shouldn't say approximately, that would be in exact form. 2 would go into 180, 90 times. So theta here would also be equal to 270 divided by pi degrees, or approximately, you got to go grab my calculator, got to turn it on, 270 divided by pi would be 85 point, let's call it 944 degrees. And those, ladies and gentlemen, would be the two answers of theta that we would be looking for. Okay? Let's get a spot check here on the thumbs. Thumbs up, we're good. Thumbs to the side, we could use a little more work. Okay, see those with cameras on, I see thumbs up. I love it. Okay. What I'd like you to do now is I would like you to try this particular theta times r equals arc length problem. Find the length of an arc intercepted by a central angle, so that is going to be theta, because it's in radians, and this is going to be r, because it says that that's the radius. So we've got S equals theta times r. Theta is 2.5. R is 8. 2.5 times 8 is going to be 2 times 8 is 16 times 0.5 is 4, so that's going to be 20. I'm going with my arc length here is 20, and we are in inches in this problem. Yay? Nay? Thumbs? Good, good, good. Love it. Okay. One last one. Oh man, I cut way down on my time this time. That's good. Went a little long in the last class. Okay. So let's try, you try this one here now. Figure me out what the arc length intercepted by that one is. Oops, I forgot to push pause. Everything's working still. That's a good thing. All right, so we got a central angle of 60 degrees right there. That is not my theta, right? Because theta needs to be in radians. So first I have to take my 60 degrees and I first have to multiply it by pi over 180 to get my radian measure of pi over 3. Okay? So that is the theta that I am going to go with, is pi over 3. My radius is still going to be 9. Okay? So now I can go to S equals theta times R. So my theta is going to be pi over 3, and my R is going to be 9. Pi over 3 times 9 gives me an exact answer here of 3 pi inches. Okay? But we would also accept the decimal equivalent of 9 point, let's go 425 inches there. Okay? And those would be either one of those. I would prefer the 3 pi inches as your answer, just for the simple fact of it's exact. Okay? All right? That is all that I have for you on this White Wednesday. If you are one of those in this class that are missing some things, there are some things that are missing. Remember, 3 tests, 6 reviews, 6 other homeworks from Chapter 3. Please get those to me as soon as possible. If not, tomorrow you will have a video on speed chart, what we like to call the speed chart, and Friday you will have a formative assessment that you'll have to do over the weekend. Okay? So have yourselves a great, grand, and wonderful day. I'll be hanging out here in class for a couple minutes if you have any questions, comments, or clarifications. Otherwise, we will see you later.